hydroxide, you're going to form blue precipitate. Blue solid precipitate, okay? Then, it's better for you to use hot press. The hot press is another, no, it's another cabinet. You're gonna, and then you're gonna have that many hot press. But after the first reaction, you can take that, take the hot press and then use it. Now, when you're going this experiment, whenever you're going to heat something using the hot press, make sure, okay, this is a vent. Okay, that's not a decoration. Okay, that's a vent. So I'm going to turn on the vent. To the vent, then you're going to heat. So you want all the vapor sucked out from the beaker into the vent. If you don't do that, if you have a hot plate here and then you're warming it up, I can smell it. Then that means that you have not listened to me. You are not putting the hot plate close to the vent and then try to get rid of the vapor coming out, okay? Understand? So you have a copper hydroxide precipitate in the beaker. You're going to heat it, not to boil. You're going to heat it until the color change, okay? 10, 15 minutes. This is a process you cannot rush. You cannot rush it. Every step you cannot rush it. Okay, there's no time for you to say, oh, okay, I got to do something. But now, when you have to go out, get a bite, you're gonna leave it while you're cooking. Okay? You can't say, oh, I'm hungry, I'm going to go out and get a bite. No. If you're going to go out, you must let me know. So I can watch for you 5 minutes or so because you're boiling, you're cooking. So like I say, you're going to heat it up, not to boil. But here, you put on hot plate, and then you run out, say, I'm going to have a sandwich. Okay. I'm going to quick bite, 10, 15 minutes, nobody is watching. Okay. What happened? You're going to dry this, and then everything, you have to start from the beginning. Okay? So if you have to go out, eat, or whatever, you have to go out while your reaction is going, let me know, okay? Let me know. You cannot just go out and then nobody's watching whatever you're cooking, okay? So here, you heat, you're cooking, okay? 10, 15 minutes, blue solid is going to become copper oxide. What's the reaction? This is a decomposition reaction. You heat it, it becomes a copper oxide, water, and it's a black solid. Okay, now this is gonna, you're gonna have lots of patience. Without any patience, you're gonna screw yourself. Okay.
Sorry, can you repeat that?
Huh?
What did you say?
You're gonna mess up yourself. Yeah. This you have to heat it. Okay, you have a black precipitate foam, and then you have a that solution. Okay. you're gonna decant it. The question is gonna ask you when you pour the liquid out, what are you pouring out? Okay, you see, all the step you have some excess. You have an excess nitric acid, excess sodium hydroxide. So when you decant, you take them out. Okay, so here you're gonna let it sit. Black precipitate, you're gonna let it sit. You cannot tell them, hurry up, sit in the bottom. Come on, I'm running out of time. No, you cannot force it. Okay, so depend on some people have a precipitate settle down really fast. Some are in the suspension for a long time, and you come to tell me how come mine will not sell? Well, it's your luck. Okay, you have to have a patient let the precipitate settle. Okay, so after it settle, you're gonna decant. What's a decantation? For clear water. Then after it settles, you can see there's two distinct layers. One is a clear water, colorless. One is a black precipitate. So you're gonna decant. Now, this is technique for you not to mess up. Okay, you're gonna decant. You can take another beaker. So you're gonna pour the water, the clear water, into the beaker. Just in case some of the solid accidentally jump up and then you pour it get into the beaker. Okay, but you still have a beaker there to capture it. Okay, after you decant as much water as possible, then this another beaker which has some trace of copper oxide, right? So you're gonna get another beaker and then you're gonna pour it and then try to capture the copper oxide. Accidentally you pour it out. Everybody follow me? Huh?
Do you think that it's going to happen, that copper is going to leave into the other beaker, or is that just what it...
What will the copper leave? This is copper oxide.
Yeah. Do you think that it's going to leave?
Depending on the technique you pour it.
Okay.
And if you don't wait till it settle, you will see in the suspension. So you're gonna pour everything out. Well, you got to wait until it settles.
So it won't happen in probation.
Right. You still kind of say, hurry up, I'm waiting. Okay. And now, when you're heating on the hot plate. This is what a lot of people.
What is it? If it gets full, I can always put it on YouTube and then keep deleting, keep recording. Mm-hmm.
Okay. We're going to use B. What would this glass B do? Would this do? Huh?
Stop the bubbles.
To
Even heating.
To have even. So now, if you use glass B, okay, you're gonna put it in the copper oxide while or copper hydroxide when you pour it. This is gonna stay. This is gonna stay with the solid. After you recover the copper, those glass B is gonna stay with you. Don't throw them out. Okay, after doing the experiment, I want to collect the glass B you will use in this step. Okay? Yeah?
What would you recommend is the best procedure to removing those from your precipitate?
Use a
Like
forceps.
forceps.
Oh, no. Remove the precipitate.
No, to remove the glass beads from the
Oh, it's
precipitate.
a forceps, but sometimes the copper oxide might hang on to the surface of the glass bead, right? think, if it's entirely clean and white, you can use a forceps to pick it up. But if you can separate them out, some copper oxide is going to be on the surface. Well, find a way, to get it out. If you don't, that's fine, because at the end of the experiment, you're going to pick it up and just give it back. That's it.
Okay, so but the loss,
No,
loss isn't a big deal.
gas speed is not going to enter in your calculation. It's an inert. Not to happen. Just only listed to prevent your bumping. Okay. Now, if you heat too fast, too much heat, I suggest put the watch glass to cover. Okay. Just in case it bump, come out, watch glass will be able to catch it. But if you bump and last out, if you cover it, well, we have 2 days. Start over. If you have close lots of a couple, right? Then you are not going to get 95% or above recovery. You're going to have 80%, 85%, or that's going to affect your grade. So you want to minimize the loss as much as you can. Okay, any question? So you're going to heat, gradual heating. Okay, it's not to boil, but you see it. So that's why you have to pay attention, because if you are heating and then you go out, you're going to have a sandwich without letting me know, and I cannot